Good morning, Algebra 2, and welcome back to another week. Kind of getting down to the final stretch, okay? So let's really dig in, finish strong. Many of you have already done this, but if you haven't, please make sure you finish Chapter 10 up, okay? Submit the test on probabilities so we can get that all taken care of. And now we're moving into our final section on sequences, okay? So, a sequence. This is going to be a list of some sort, okay? And in our case, it will be a list of numbers. And there's going to be some sort of order to these numbers, okay? So they have a certain order. Now, maybe that means they're all going up, maybe they're all going down. There's some sort of consistency about them, though. It's like a pattern. And we can continue to see that pattern unfold throughout the sequence, okay? Now, each specific number in this sequence is considered to be a term. Okay, so a term is one of the numbers in your sequence. And we'll talk more about the terms as this week progresses, but just know that within the pattern or within the sequence, each spot is a different term. Okay, now we have a couple different types of sequences we're going to deal with. The first one, arithmetic sequence or arithmetic sequence. Okay, I don't care how you say it, but we're going to represent this. When we find this, we're going to write the letter A for arithmetic or arithmetic. Okay, and this is when there's a constant difference. So the difference between one term and the next is constant. Okay, maybe it's going up, maybe it's going down. If it was going up, that means some sort of addition is happening. It's going down, some sort of subtraction is happening. Okay, but we know it's going to be consistent throughout. Okay, it's a constant throughout. And this D here represents that common difference because, as we said, it's consistent. All right, now our next one, geometric sequence. This one we're going to represent with the letter G, and this, rather than adding and subtracting, is multiplication or division. And it's found by multiplying the previous term by a constant. This constant, okay, this consecutive thing sorry, I misspoke. This constant number that we're multiplying it by, we're going to represent that with R. This is our common ratio, okay? And each term we will multiply by something to get to the next term. Now, division and multiplication apply here. However, we'll kind of talk about this. Since we're doing a common ratio, we're always going to be multiplying. Okay, so instead of multiplying, instead of dividing, we're actually going to multiply it by a fraction. But we'll talk more about what that means when we get to that. And finally, sometimes there's a pattern, but it doesn't follow either of these rules. It's not consecutively adding or subtracting. It's not consecutively multiplying. So instead, it's neither of these, and we're going to represent that with an N. However, there still could be some sort of pattern. Okay, so if we look here, first we want to figure out the next two terms. And then it doesn't say this, but we also want to be able to kind of write, is it arithmetic, geometric, or neither? And then once we find that, what's the difference or the ratio? Okay, so this first one, 2, 7, 12, 17. Okay, as we go, each time it is gaining 5. So our next number, I'll get my pen back, is 22, and then 27. So as we said, each time it is gaining 5, it is adding 5. Since it's adding, think arithmetic. Okay, so that's an A. And our common difference, as we said, is plus 5. Each time it gains 5. Okay, if we look at letter B here, this time 41, 39, 37, 35, 33, you guys can probably figure it out. It's going to be 31 and then 29. Okay, this time it is not adding, subtracting, but we are still considering this an arithmetic sequence. However, instead of our common difference being positive, it was subtracting 2, so it's going to be a negative 2 each time. Okay, now the next one, 4, 12, 36. Hopefully you guys are recognizing that each time 4 is getting multiplied by 3. Okay, if it's multiplied, we're going to consider that a geometric sequence. And our R, or common ratio, in this case is 3 because that's what I multiply by. So 4 times 3 is 12. 12 times 3 is 36. 36 times 3 gives us 108, okay? And then 108 times 3 gives us 324. And if you can't do those in your head, that's fine. Use your phone, use your calculator. You just got to be able to get the right answer, okay? Now, our next one, letter D. This is another example of a geometric sequence. So I'm going to put a G. 64, then 16, then 4. Some of you might think and notice each time we're dividing by 4. But as we said earlier, let's scroll back up. Our geometric sequence is found by multiplying the previous term by a constant. We always want to multiply. Okay, so rather than dividing by 4, we can still get this by multiplying. Okay, dividing by 4 over here, I'll write this, is the same as multiplying by 1/4. Okay, multiplying by 1/4 is the same as dividing by 4. So our R, our common difference, is 1/4. And you can multiply that into the calculator, or if you're doing it on your own, just divide by 4. It doesn't matter which way you do it. 4 times 1/4 would be 1, and 1 times 1/4, our final term here will be 1/4. Okay. Now, it just so happens that that was the same. That's not always going to be the case, but in our case here with example D, our final term that we were looking for is the same as the common ratio. Okay, now the last one. If we look 1 to 10, so maybe you would think multiply by 10, 10 to 2, nope, doesn't work. So 1 to 10, add 9, but 10 plus 9 would be 19. So nothing constant is happening. Okay, we're not either adding or subtracting something constantly. We're not multiplying constantly. Okay, so 1, 10, 2, 20, 3, 30. However, there's definitely a pattern of sorts. Okay, so this is going to be a sequence that's neither geometric or arithmetic. Okay. However, 1, 10, 2, 20, 3, 30, 4, and then 40. Okay. There's still a pattern. And then our final one, once again, 1, 1, 2, 3, 5, 8, 13. Okay. This is neither arithmetic or geometric. However, this is a very famous sequence. Okay. So our Fibonacci sequence is talked about in many different parts of nature. As you look, if we add the first two terms, 1 plus 1, we get 2 right here. Okay, then 1 plus 2 gives us 3. 2 plus 3 gives us 5. 3 plus 5 is 8. 5 plus 8 is 13. Each time they're adding the previous two terms to get the next one. So 8 plus 13 gives us 21. And then 13 plus 21 will give us 34. Okay, so that's another example of a sequence. So the big takeaway from today's lesson, a sequence is when we have some sort of consistency happening. It's a list of numbers that have some sort of order about them. Okay, and now we need to take the different types. Arithmetic, this is when we're adding or subtracting, and we can use D to represent the common difference. And then G is our geometric sequence. This is more when it looks like it's multiplying or dividing. However, we're always going to multiply, find our common ratio. And once again, if we're dividing by 4, that's the same as multiplying by 1/4. In case you can't make the connection, if we are dividing by 6, that'd be the same as multiplying by 1/6. Whatever the number is you want to divide by, you can just multiply by a fraction or the reciprocal of that, so 1/6. Okay, so please take today, get our short lesson done, and reach out to me if you have any questions. Be sure to join the chat this afternoon. Hope you have a great day, and talk to you soon.